So we are going to look at logarithms. And again, because, last year was last year, I'm pretty sure for probably all of you, logarithms was something that you did during the quarantine, which meant it was on Edgenuity, and who knows if you really understood it and how much of it was in there, and I don't know. So I'm going to kind of take it back and get a little basic here. So before we even start on here, I'm going to show you a quick 3-minute video that's a pretty good explanation of that. In order for me to do that and everything work out right, I need to mute this and turn the speaker off so that I don't blast anybody's ears weird.
How does the difference between 0.00000000398 and 0.00000000398 cause one to have red eyes after swimming? To answer this, we first need a way of dealing with rather small numbers, or in some cases extremely large numbers. This leads us to the concept of logarithms. Well, what are logarithms? Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation, b raised to the p power equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time, this will be written log base b of the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What is the value of log base 10 of 10,000? The same question could be asked using exponents. 10 raised to what power is 10,000? Well, 10 to the fourth is 10,000. So log base 10 of 10,000 must equal 4. This example can also be completed very simply on a scientific calculator. Log base 10 is used so frequently in the sciences that it has the honor of having its own button on most calculators. If the calculator will figure out logs for me, why study them? Just a quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, use your fingers. 2, 4, 8, 16, 32, 64. So log base 2 of 64 must equal 6. So what does this have to do with my eyes turning red in some swimming pools and not others? Well, it leads us into an interesting use of logarithms in chemistry, finding the pH of water samples. pH tells us how acidic or basic a sample is and can be calculated with the formula pH equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of water samples with hydrogen ion concentration of 0.00000000398 and 0.00000000398 quickly on a calculator. Punch negative log of each of those numbers, and you'll see the pHs are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice on your eyes, but the pH of 8.4 will make you feel itchy and red. It's easy to remember logarithms. Log base b of some number n equals p by repeating the base raised to what power equals the number. The base raised to what power equals the number. The base raised to what power equals the number. So now we know logarithms are very powerful when dealing with extremely small or large numbers. Logarithms can even be used instead of eye drops after swimming.
Explanation of logarithms, and I want you to think about, have you ever gotten a question wrong and you were like, I was only off by a decimal place? I mean, think about that 0.000000398 and however many zeros it was. I mean, as far as the value of that number, it's only one decimal place off, and it's not even that much of a difference of a value, but when you talk about it as pH levels, it's a huge difference. And so, that's why being exact is very important. So probably if you've only taken chemistry, like as a 10th grader, then y'all probably didn't use logs, but I would imagine in AP chemistry you probably definitely would, and in your other sciences, because it even said logs are used so frequently in the sciences, and math is a science, but it wasn't talking about like you just have to know it for your math classes, that sort of thing. Like tons of applications with logs. So the way we read this, log base b of a equals x. So I have different letters than they did, but they mean the same thing because letters could always be anything. But it is nice that the base is b. We'll just keep it that way. So the base of the log becomes the base of the exponential. And then you just kind of go around in a circle. The base to this power equals that number, so b to the x power equals a. So we should be able to convert back and forth between the two forms, okay? Eventually we will look at these on a calculator or use the calculator for this, but today everything is non-calculator. You kind of have to know how to understand them both ways. So the only time you wouldn't have a base here is if the base was 10. It's the only time you wouldn't have a number here because that's called the common logarithm. So a logarithm with base 10 is called the common logarithm. So this says log base 10 of x. It's real. Oh, goodness. It's really written as this. It's kind of like when you have an just a variable, you know the exponent's 1 and you don't put it there. If it's log base 10, you just know it's a 10 and you don't put anything there, okay? Any questions at all at this point? All right, so let's do a few of these. So right now we're just rewriting them. We are not solving anything because there's nothing to be solved. So if I have log base 7 of 49 equals 2, the base is 7, so it would be 7 to the second power equals 49, and hopefully it's super obvious that that is a true statement, right? So on number 2, what's the base of the log? 10. So this would be 10 to the third power is 1,000. Okay, so just rewriting the forms. So y'all go ahead and do 3 and 4 on your own, and then I'm going to use my random caller from Delta Math to get y'all to help me. The only problem with them here is that not everybody's actually here, so it makes it a little bit more challenging. We'll have to go through some names. But this random caller, as opposed to one I've used before, will call you again and again because it's truly random. So it doesn't necessarily go through everybody before it calls you again. All right, so let's see who's going to help me with number 3. See? Nope. Oh, Angela. All right, what would I write for number 3? Okay, y'all agree with that? Yes, very good. Thank you very much. And then, let's see who's going to help me with the next one. Jessica, sorry. What would I write, sweetheart? Jessica, are you there?
There's no Jessica in Zoom.
Oh, it says that there. Is it just you? Oh, she just jumped out. I think mine's like behind or something. Okay. All right, well, David, since you're talking to me, why don't you help me out with this?
4 to the power of negative 3 equals 1 over 64.
Very good, thank you. All right, thank you. She was there, and then I guess, I don't know if there's a delay or what. All righty. Any questions about those? So let's rewrite them the other way. It says write each equation in log form. So the base of the exponential is 3. So this is going to be log base 3 of this number, 1 over 81, equals negative 4. We all agree with that? And remember, if you just look at the exponential part here, this to the negative 4 power, that negative moves it to the denominator, and then you get your 4th power. That's the way that works. Okay, so 8 to the 0 power equals 1. We agree with that, hopefully. So we're going to do log, the base is 8, log base 8 of 1 equals 0. So now knowing that, what we started with, what we ended with, what do you think log base 5 of 1 would give me? 0, right? Because if log base 5 of 1, that would mean 5 to what power gives me 1 is going to be 0. So this base right here, this 8, could be any number other than 0, and I would still get a 1 out of it, right? So the log of any base of 1 is going to give you 0 every time, okay? So just FYI. All right, so y'all rewrite 7 and 8, and then I will get somebody to help me. David just helped me. Angela calls you again. She's calling the same people. All right, Tan. Give me number 7. Very good. Log of 1/10 equals -1. Now, he didn't tell me a base. Is that okay? Yes, because we know then that that is log base 10. Very good. Okay, I might give up on this in here. It's going to call everybody that's not here. The same people over and over again. Bianca. Number 8. Wait. Oh, I'm sorry. I put in equals. Yeah. Sorry. And I wasn't right what you were saying anyway. Okay. 2 squared root of 3. Okay. Equals 1/2. Okay. Thank you. All right. We good? So that 12 to the 1/2 power, how else could I write that? Like if I just wanted to rewrite this, like how else can I represent this value? Square root of 12. Good. Make sure you know what's going on with your fractional exponents. 12 to the 1/2 power is the same thing as the square root of 12, and the square root of 12 is 2 square root of 3. Okay, very good. All right, so now we're going to actually evaluate some based on all that stuff that we know right now. So I want to know what this value actually is, so I'm going to set it equal to x. And then I'm going to rewrite it in exponential form because we understand exponential form way better at this point. So I'm going to get 6 to the x power equals 36. Now, you may already know what x is, okay, and that's all fine and good. But some of these are going to be super easy where you can just look at it and know, and some of them you're going to have to do some stuff. And so if we don't do the stuff on the easy ones, we're not going to know what to do when we get on the more complicated ones. So what we want to do is we want the bases of the two sides to match. So I can use 6 as a base over here. So I can make this 6 to the x power equals 6. Well, 36 is 6 to what power? 2, right? So 6 to the x equals 6 squared. That's the same as this. So then since the bases are the same, that tells me x equals 2. Okay, make sense? So yes, I want you to have that extra little step in there because it's going to be necessary for some. All right, so we will set this equal to x. Then I can have 2 to the x power equals 128. So I want the bases to be the same, so 2 to the x equals 2 to some power. And then I count on my fingers when I do this. Go 2, 4, 8, 16, 32, 64, 128. So that makes it 7. So x is equal to 7. There's no shame in counting on your fingers, okay? None at all. I mean, if you're having to add 2 plus 3, maybe, but you know. Okay, so number 11. Log base 3 of 1 over 27 equals x. So that's going to give me 3 to the x power equals 1 over 27. So I'm going to make my base 3. Since the value here is in the denominator, I need to switch it to the numerator, so that means it's going to be negative something. And it's going to be 3 to the negative what? 3rd. So now that the bases match and it's the same value as this, then x equals negative 3. Everybody okay with all that? All right, number 12, we're going to make that equal to x. So I get 9 to the x power equals 1. All right, well, I want my bases to match. It's going to be much easier to use 9 than it is 1. So I can do 9 to the x power equals 9 to the what? 0 power. Very good. So x equals 0. Right. Any questions at all? Awesome. We're going to do probably one more together and then I'll let you. Well, we might do a couple more together. All right, so number 15. I'm going to set this equal to x. What's going to be the base of my exponent? 10. So 10 to the x power equals 1 over 100. So I'm going to make my base 10. And so 10 to the x will equal 10 to the what? Negative 2. Very good. So x equals negative 2. All right, so let's look at 16. I'm going to set this equal to x. So I get 16 to the x power equals 2. Now, there is a way for me to make this, the base be 16 on both sides, but that makes it more complicated. But instead, I know I can change 16. I can use a base of 2 for 16. So I'm going to have 2, and then 2 over here. This will be 2 to the first. And then 16 is going to become 2 to some power to the x power, right? And so 16 would be 2 to what power? Count on your fingers. 2, 4, 8, 16. So it's 2 to the 4th power. So the 16 became 2 to the 4th. I still have to take it to the x power. What is your rule for power to a power? What do I do with the 4 and the x? Do I add them or do I multiply them? I multiply them. When it's power to a power, you multiply. So this is really 2 to the 4x power equals 2 to the first. And I'm fine with you skipping this step. I just didn't want to skip it the first time so you understood where everything was coming from. So now that my bases are equal, I can set the exponents equal to each other. So 4x equals 1 and x equals 1/4. What questions do we have? All right. So let's look at 17. Set this equal to x. So I get 16 to the x power equals 1 over 32. So I'm pretty confident I don't want either one of those numbers as my base. I know that I can use 4 as a base for the 16. Would 4 work for a base for 32? No, because 4 times 4 is 16, times 4 is not 32. So what am I going to need to use for my base? No, because I got to go the other way. It's going to have to be 2. Like, I can divide 8 into it, but I can't take 8 to a power, yeah. But that's why I'm asking those questions, because it's easy to get that all mixed up in your brain. All right, so I'm going to have 2 as a base on both sides. Well, we already figured out that 2 to the 4th is 16, so I got to keep that x. This is 2 to the 4x power. This is going to have to be a negative. And don't reinvent the wheel every time. Think about this. If 2 to the 4th is 16, 2 to what power is 32? The 5th. You just have to multiply it one more time, all right? So it's the negative 5th power. So that means that 4x equals negative 5, so x equals negative 5/4. Okay. We good so far? All right. You work on 18. Okay, instead of having one of y'all help me with it, I'm just going to talk you through what happened last period because it was a pretty good teachable moment. So I had somebody walk me through it, and I said, okay, what are you going to have your bases be? He said 4. I said, all right. So I'm going to do 4 to the x and then 4 over here. I said, all right, so then what would your exponent be on the right-hand side? So he thought for a minute, and he goes, oh, I can't use 4. I said, well, why can't you use 4? He said, well, 4 times 4 is 16, times 4 is 64. If I multiply 4 again, I'm not going to get 128. It's more than that. So, like, that was his initial thought, like, I'm going to use 4, and then he realized he couldn't. And that's fine, because that's kind of how the whole process works. Sometimes you go, oh, can't use that one, so I need to reevaluate. What am I going to use for my base? 2. So I can use 2 for both of them, right? And I know I'm going to have to keep this x. Well, to get 4, that's 2 squared, so it's 2x over here. And this would be 2 to what power? 7. So I get 2x equals 7, and x equals 7 over 2. Okay. Any questions at all? So it's fine if the first thing that pops in your head doesn't always work. I mean, that's thinking. I mean, that's how you work through things. Okay, so we can't always get equal bases. If you look at number 21, before we talk about the rest of this, this is base 20, so this would be 20 to the x power equals 4. Well, I'm not going to be able to get common bases there to be able to do it this way. So I'm going to have to, most likely in the end, use a calculator. We're not today because we're only going to do part of this process. But this says some logarithms are not as easy to evaluate as those above. This will require the change of base formula. So we changed them to base 10 because it's on the calculator easy. Now on these calculators, you can actually do log base whatever, but it's usually a little bit harder to get to. You got to push some more buttons, but we have to know how to change the base for other reasons anyway. So if I have log base b of a, another way to write this is as a fraction with a log in the numerator, a log in the denominator, and they're both base 10. So then you just have to get the a and the b in the right place. And it's pretty easy to do because the b, which is the base, goes on the bottom, and the a goes on the top. So if you just think the base goes on the bottom, you can knock these out all day long, no big deal, okay? So if I had, a super basic calculator that didn't do other bases and I needed to get an actual value for number 21, then I would have to change my base. So this does say approximate, but we're not typing anything in right now today. So I know that this is going to have to give me a fraction with a log in the numerator and a log in the denominator. And we're going to have a rule tomorrow where we're going to have fractions, but we're not going to have a log in the numerator and denominator, so we want to make sure we keep these separate. Then the base goes on the bottom, that's 20, and the 4 goes on the top. So log of 4 over log of 20 would be the same as log base 20 of 4. Give me the same value. All right. So go ahead and fill in the next 3. They should be pretty simple to get filled out. All right, then we'll just go through these together. On 22, what's the top number? 2. Bottom is 6. 23, the top is 225. The bottom is 3. 24, the top is 1/2. The bottom is 8. See how easy that is? So we just do a few of them as repetition. Hopefully that isn't going to be a crazy hard thing for you to do. Okay. So we have talked about all of those with just your basic logs, but we need to talk about natural logs. Because remember, we had e that we were graphing with the other day. So a logarithm with base e is called a natural logarithm, because it was a natural base for the exponential. We've got a natural logarithm. So this log base e of x, this will probably be the last time you'll ever see it written that way, and we don't write it that way. It's a natural log, but instead of doing n and l for natural log, it's ln. So ln of x. That's a lowercase l and an n. It's not the word N-I-N, no I's there. So natural log of x is how you say that. And then when you say that, you just know that the base is e. Okay, so we're going to look at converting natural logs and exponentials back and forth. So this says write each equation in exponential form. So on 25, I have the natural log of x equals 4. So when I want to change it to exponential, I know since it's a natural log, the base is e, and I do it just like the other ones. E to the 4th power equals x. So you go ahead and do 26. Then, Gwyneth, can you tell me what I would write? Is it 10 or is it x? You always have to go on the other side of the equal sign. So look, you got the base, you go to the other side, and then you get to the x power, and then that equals 10. Make sense? All right, any questions at all about those? All right, so then we're going to write each equation in logarithmic form. So this is e to the x equals 50. So the base is e. Since the base is e, it is a natural log. I go to the other side of the equal sign. Natural log of 50 equals x. All right. Then y'all do 28. Giselle, tell me what I would write. Okay, very good. Y'all agree with that? Awesome. So your assignment today is in Delta Math. It may kind of look like a lot when you get in there, but there's only like 2 questions in each little section because I was trying to force some certain things to happen. And plus, overall, a lot of them is just converting, and there's not a whole lot of work. It should be quicker than some of the assignments that were shorter. Oh, and I almost forgot the most important thing. Since yesterday was election day, and you're probably tired of hearing about it, even if you're not trying to listen to it, here's a map that I saw yesterday on the internet. So I don't even know if it's right, but if it's on the internet, it must be right. So it just cracked me up. If you're sick of looking at, voting maps in the red and the blue, this is a map of kangaroo ownership in the United States, like what the laws are. So the red states, it's illegal to own a kangaroo. In the orange states, you can own a kangaroo with a permit. So in case you didn't know that, you could have a kangaroo in the backyard with a permit, because we live in Texas. And then if it's green, you can own one. You don't even have to have a permit. So bring it on. So there's a map that's much more interesting than your political map. Okay. Mm-hmm. Oh, that's funny.